Hello, ladies and gentlemen. Excuse me. Welcome to the last video of Unit 10. And this is talking about exponential growth and decay. And if it sounds familiar, you have talked about this before a little bit. Maybe just not in this manner, kind of knowing what we know about logarithms now. So let's kind of look at how can I use logarithms to help me solve problems with decay and growth. So decay, growth, certain assets like homes can appreciate, so keyword there, so pay attention to look for appreciate or depreciate. Appreciate means increase in value over time. Depreciate means decrease value over time. So if you buy a car for $22,000 and the decrease is by 16% each year, that means it's going to get cheaper for each year. So if I look at this, it's going to be a function that looks like this. So the price of the car, if it depreciates by 16% each year, would look like this. So it would be y equals my initial starting amount, $22,000, and then if it decreases by 16%, that's going to be 0.84. Okay, what I did was I switched it to a decimal. So I switch it to a decimal, and then since it's decreasing by that amount every year, I'm going to take 1 minus that, and I'm going to get 0.84. That means, so this is going to be raised to the function of time. So if I'm looking for the car for 2 years later, so I'm going to take 22,000 times 0.84 raised to the second power. So now it just becomes a matter of order of operations. 0.84 squared times 22,000. So after 2 years, that same car that you paid $22,000 for is only worth $15,523.20. So that's going to be that for 2 years later. If I do it for 3 years later, same idea, raises to the third power. That's going to be down to $13,039.49. Then if I jump to 7 years later, so I swap that in for a 7.84 raised to the seventh times $22,000. That's only going to be $6,491.99. That's depreciating at a pretty good clip. So exponential decay is when a quantity decreases by a fixed percent each year, and the amount y of that quantity t is given by this function. So you take your initial starting amount, I'm sorry, back up. That's not your initial starting amount. This is your initial starting amount. 1 minus your rate, time, gives you the current time. So a cup of coffee contains 130 milligrams of caffeine. I know some of you know that function well. So the caffeine is eliminated at a rate of 11% per hour. How long will it take for half the caffeine to be eliminated? So what you're trying to do is look at this and go, my initial starting amount is 130. My rate is going to be 1 minus 0.11. And I'm trying to figure out when it gets cut in half. So I'm trying to figure out when is that going to equal 65. All right, so now it becomes a function of where I'm probably trying to use log. So I get 65 equals 130. 1 minus 0.11 is going to be 0.89 raised to the power of t. So what I'm going to do is divide this by 130. So that's going to be 1/2 times 0.89 to the t. So now here's where I would do a log of both sides. So when I do that, this can be moved out front. Okay, so I'm going to have log of 1/2 equals t times the log of 0.89. So now a little division here. Divide by log of 0.89. So if I take the log of 1/2 and divide it by the log of 0.89, I get an answer of 5.95 for an answer. So it's going to take approximately 6 hours for your amount of caffeine in your body to get cut in half. So if I'm looking at decay, decay looks like this. I'm subtracting it each time, final amount, initial amount, percent decrease. So if I look at this, number 2, store is offering a clearance sale for each one for a camera. The original is $198. It's dropping 10%. Dropping 10% each week until all the cameras are sold. How many weeks will it take for the price of the cameras to drop below half of the original price? So again, I'm looking for a time. So this time, the time is not in years, it's in weeks. So what I'm going to do is set my initial amount, 198, 1 minus 0.10 to the factor of time in this case being weeks, and I'm trying to figure out when it's going to be below half. So 198 divided by 2, half of that's going to be 99. So now it becomes a problem where I'm going to use a logarithm to solve. So 99 equals 198.9 raised to the t. So divide by 198. But we know that this is the left side. This side here is going to be 1/2. Oop. Yeah, don't do that. This should be a t raised up here. That's an exponent. So now I want to take the log of both sides. So that's going to be log of 1/2, log of 0.9 raised to the t. Then the t can be moved out front. So that's log of 1/2, 0.5, same thing, t times log to the 0.9. So now divide both sides by log of 0.9. And there's your answer. Log of 0.5 divided by log of 0.9 is going to be 6.5788 equals t. So it's going to take a little over 6.5 weeks, 6.5 weeks for it to drop below 50%. All right, so in the context of the problem, it's going to be 7 weeks before it drops below 50%. All right, so exponential growth is good news. That's where things get grow in value. So if a population in a city is 120,000, it's increasing at 1.5% per year. From 1910, what's it going to be in 2010? So my initial starting amount will be 120,000. I want to go 1 plus 0.015. And then 1910 to 2010, that's 100 years. So this just becomes an initial amount. This just becomes a huge order of operations problem. So 1 plus 0.015 raised to the 100th power times 120,000. It's going to be a ridiculously large number, 531,845 people. I mean, technically it's 0.478, but, you know, there's no half people running around, so just round it to 531,845 people. So that's your function. So a population of a city of 1 million people is increasing at 3% per year. It grows at this rate, and how many years will the population have doubled? So your initial amount, 1 million. Rate, 1 plus 0.03, okay? And then how many years, that's what you're trying to figure out. When is that going to be? 2 million. So now let's play around with this here. So this, if I divide by 1 million, so that's going to be 2. That's going to be equal to 1.03 raised to the t. Now, bring in your logs. So if I get log base 2, let me back up here. Log of 2 equals log of 1.03 raised to the t. But now this can move over here. So then divide so there's my answer. That cancels out. So t is going to equal log of 2 divided by log of 1.3. 2.6419. So it's going to take about a little over 2.6 years to deal with that, for that population to double. All right, so take a look. Home values in Miller Sport increase 4% per year. Mr. Thomas purchased his home 8 years ago for $122,000. What is the value of his house now? So he's got $122,000. You know, white was a bad choice. $122,000 grows at 0.4% or 4%, so that's 0.04. 8 years ago. What is the value of his price now? So you go 1.04 raised to the 8th times 122,000. So I get 166,965.42. I'm going with about that one. That matches up right there. That's what I'm going with. All right, so there's one where E comes into play. So for decay, it's going to be that. For growth, it's going to be that. K is a constant. This is mostly used for radioactive decay, so when you see half-life, those kinds of things, not talking about the video game, talking about actual figuring out half-life. This is where E comes in. All right, so the half-life of a radioactive substance is the time it takes for half the atoms of the substance to disintegrate. Carbon-14, all life on Earth has it. Half-life is 5,760 years. So every 5,760 years, half of the mass of carbon decay falls apart. Fine. What is the value of K in the equation of decay for carbon-14? So let's take a look at what we're dealing with here. So your half-life is, so you have E, and you're trying to figure out your half-life is 5,760 years. So that's going to be your time. So initially, your initial starting amount is going to be, so I'm just going to say it's 2, because you're trying to cut it in half. So I'm going to start it with 2, and you're going to figure out how long it takes to get to 1. You know what E is. You know it's exponential decay. And you know your half-life is 5760. So I'm going to solve that. So I'm going to divide by 2. So 1/2 equals E to the negative K, 5760. So now, if I have E, I want to take the natural log of both sides. So I want the natural log of 1/2. This cancels out, and bring this out, so I get negative 5760K. So I want to divide by that. So I take the natural log of 0.5 divided by negative 5760, and I get a ridiculously small number, and that's going to be 0.0. Hold on. I'm going to divide that first. It bothers me. 0.000120. That is my rate of K right there. All right, so for certain bacteria, K is 0.872. When T is measured in days, use the formula Y equals A times E to the KT. How long will it take 9 bacteria to go to 738 bacteria? So initial starting amount, 9. E is E. K is 0.872. You're trying to figure out T. You're trying to figure out when is that going to become 738. Well, first step, divide by 9. So I get 82 equals E to the 0.872 T. So then I want my natural log of both of those. So I want the natural log of 82. And then these cancel out, so I'm left with 0.872 T. Let me move this up here. Natural log of 82 is going to be 4.4067. And if I divide that by 0.872, that's going to be 5.0535. So it's going to take approximately 5 weeks to hit 738 bacteria. All right, play around with that. Use what we know about logs, and come talk to me with questions.